Hi students, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. I am Dr. Tajur Rahman and this is our lecture number 16 in the series of lectures on stereochemistry. Today we will talk about Sachse-Mohr theory. This theory was proposed by Hermann Sachse and Ernst Mohr in 1918. This theory is also known as the theory of stainless rings. The main purpose of this theory is to explain the stability of cyclohexane and other higher cycloalkanes. The stability of cyclopropane to cyclopentane was explained by Baeyer theory and subsequently by Coulson's and Moffitt modification or banana or bent bond theory. Now recall the Baeyer theory. According to Baeyer theory, which proposed that number one, all the cycloalkanes are planar. Number two, they all have angle strains. Number third, their bond angles deviate from the normal tetrahedral bond angle of 109 degree 28 minutes. Number four, they all are unstable. So this was all about Baeyer theory. Now the Sachse-Mohr theory proves the Baeyer theory is totally wrong one. How? To explain it, we can say that according to Sachse-Mohr theory, number one, cycloalkanes are not planar. Number two, they assume that they are in folded or puckered conditions. Number third, they are strain free with normal tetrahedral bond angle of 109 degree 28 minutes. Number four, cyclohexane and other higher cycloalkanes are more stable than cyclopentane. Although according to Baeyer theory, cyclopentane is more stable than cyclohexane and other higher cycloalkanes. Cycloalkanes can exist in two non-planar forms which are strain-free, that is number one, chair form, which is more stable. Number two, the board form, which is less stable. In this slide, A represent the cyclohexane while B and C represent the two chair conformations of cyclohexane. The best way to draw the chair conformation of cyclohexane is to follow the steps. That is, number one, draw two parallel lines slanted downward and slightly opposite from each other. This means that the pore of the cyclohexane carbon atoms lies in a plane. Number two, locate the topmost carbon atom above and to the right of the plane of other pore and connects the bonds. Number third, locate the bottommost carbon atom below and to the left of the plane of the middle pore and connects the bond. Note that the bonds to the bottommost carbon atoms are parallels to the bonds of the topmost carbon atom. These are the axial and equatorial hydrogen atoms. Similarly, the board form can be drawn from the chair form. If we move the carbon number 1 and carbon number 4 above the plane of other four carbon atoms of chair conformation of cyclohexane as shown. In all these structures, the hydrogen atoms are represented by red color while the equatorial hydrogen atoms are represented by green color. Although all the six carbon atoms are identical but the protons are of two types, the one type of protons stick either vertically up or down are called axial hydrogen atoms and are represented by red color while the other types of protons which stick outside way are called equatorial hydrogen atoms and are represented by green color. In both chair and board conformation, chair conformation is more stable than board conformation. It is because in chair conformation, all the hydrogen atoms are staggered due to puckered nature and the bond angle is normal tetrahedral bond angle of 109 degree 28 minutes. On the other hand, in board conformation, eclipsing interaction can occur between hydrogen atoms on carbon 2, 3 and carbon 5 and 6, as well as Planck-Pole interaction between hydrogen atoms on carbon 1 and carbon 4, due to which board conformation is less stable as compared to chair conformation. Both the chair conformation and board conformation are free from angle strain. Due to this, Sachse-Mohr theory is also known as strainless ring theory. It is because this theory proves that cyclohexane and other higher cycloalkanes are strain-free, which the base strain theory failed to explain. These are the ball and stick models and various views of cyclohexane chair and board conformations and Newman projections. In board conformation, the two axial hydrogen atoms on both carbon 1 and carbon 2 are too close to each other in space that they cause spatial interaction, and this interaction is known as Planck-Pole interaction. So thank you for watching my video lecture. If you are new to YouTube, then please like, share, comment and subscribe my channel for more new videos.